So warm greetings to one and all. Today, we have the AFOMP monthly webinar on principles and clinical applications of MR-Linac. And we are privileged to have Dr. Jiayun Chen from China as the speaker and Ms. Rahmah Hidayati from Indonesia as the moderator. And I would like to introduce Ms. Rahmah Hidayati. She's a leader in dosimetry research group and a researcher in medical physics and radiation protection in the National Research and Innovation Agency in Indonesia. She has a long career starting from early 2000s in the radiation physics and radiation protection dosimetry and safety technology. She has a number of awards, grants, and publications to her credit. And she is one of the most apt person to be moderating today's talk. And with this introduction, I would like to hand over to Ms. Rahmah Hidayati to carry over with today's monthly webinar. Over to you, Ms. Hidayati.
Thank you, Dr. Marijan. Good morning, good afternoon, good evening, everyone, everywhere. Today, I will be honored to be your moderator. And for all the participants, welcome to the 7th AFOMP monthly webinar. So as I've been introduced by Dr. Marijan, my name is Rahmah Hidayati from National Research and Innovation Agency, Indonesia, and I'm honored to be your moderator for the 7th AFOMP webinar, which will discuss about principles and clinical application of MR-Linac. First of all, I would like to introduce our honorable speaker, Associate Professor Dr. Jiayun Chen. How are you? From Department of Radiation Oncology, Cancer Hospital, China's Academy of Medical Science. She holds a PhD in particle physics and nuclear physics from Institute of Particle Physics, Central China, Huazhong Normal University. Dr. Jiayun has the research interest in improving the quality, efficiency, and consistency of oncology radiotherapy through new methods and techniques in medical physics, especially in two main research areas, in magnetic resonance guided radiotherapy and radiotherapy planning, optimization, and automation. Okay, and Dr. Jiayun, I hope you are very good today to share your knowledge and your experience in clinical application of MR-Linac. Please, Dr. Jiayun, floor is yours.
Hello, thanks for introduction and show my slides. Can everyone hear me?
Yes, it's good.
Yes.
Okay. Okay. Hello everyone. I'm Jiayun Chen from China. I worked as medical physics in Cancer Hospital, Chinese Academy of Medical Science. The subject of my talk today is principle and clinical application of MR-Linac. And my talk will be in 6 parts. In the first part is the introduction of MR-Linac. Then in the second part, I will present the technical characteristic of this work. In the third and fourth part, the patient admission and treatment process will be illustrated. After that, I will introduce the treatment planning part of our MR-Linac unit. Finally, is my view about the future perspective of MR-Linac. Okay, let's come to the term of the introduction. As we all know that it's a physical challenge to integrate MR and Linac. MR scanner and Linac are highly sensitive to pieces of medical equipment with mirror electromagnetic interface. In the word of Dr. Furlong, these two machines are allergically to each other. I prefer call it the iceberg and the flame, 冰山与火焰 in Chinese. From the perspective of MRI, a Linac is a medical source that degrades the magnetic field uniformity which is integral for image. In addition, the Linac is a source of radiation frequency interface that can also cause image artifacts. So the successful of integral of the original incompatible MR system into a Linac system is a significant challenge technical achievement. Up to now, there are 4 company and institute has introduced them, including MR-Linac from US,
Max
Unity,
इसमें एक और स्टाफ है
Unity from Sweden, Aurora RT from Canada, and the Australian MR-Linac. Why we use MR-Linac? Because MR-Linac present much better clinical benefits compared with the conventional Linac. The example shows here is the liver cancer. So in the pre-treatment image, super image of soft tissue, clear visualization of the tumor and host tissue image was acquired using MR-Linac compared to the conventional Linac. And during the treatment, the adaptive plan and the gate should be routinely used available due to a better and improved image quality provided by MR-Linac. And the routine obtained image with function image could help the mapping of the different aspects of the tumor biological and present an opportunity to personalize treatment. The MR-Linac is clarified into the perpendicular and inline system based on the radial orientation of the Linac, the radiation beam and the static magnitude. The figure shows in the left is the perpendicular system, and in the right, inline system. The decision has major implication for every aspect of the system design with advantages and drawbacks for each choice. For the effect of field on on the therapy beam, the perpendicular system present major effect. Magnetic field bands charged particle and affect beam generation and dose in the patient, while the inline system have a minor effect on the magnetic field aligned with the particle beam direction. For the effect on the MR technique, perpendicular system could adopt closer to standard hardware. Meanwhile, specialized hardware have to design are acquired in the inline system. How about the beam angle? The Linac can be rotated independently of the magnet in perpendicular system, while in inline system, either the magnitude or the patient must be rotated, maintain the configuration alignment. So based on this, we figure out that in the perpendicular system, less hardware and software will be changed compared to conventional Linac. So in the conventional, that's why the perpendicular system are the first conventional by V-Ray and Elector. The left 2 lines in the table is MR and Unity are perpendicular system have been launched for commercialized. MR used the Cobalt initial and 6 MV Linac after July 2017 combined with 0.35 Tesla MR system. Unity integral 7 MV flight free-to-free Linac system and 1.5 Tesla MR system. The alpha OV of both systems are 17 cm, and the third and fourth part in the table, RT has the first patient treated in February 2023, and no clinical data is reported. RT used the 6 beam energy Linac with 0.5 Tesla MR system and with a 110 plus 16 cm of size. The Australian MR is actually in development. There are 2 beam energy available. One is 4, the other is 6. With the 1.5 MR system, the office size is 16.2 cm. And our hospital choose the Unity as our first MR-Linac. The left figure is the machine room of the Unity. We began the Unity Commission in July 2019, and it took 3 months to finalize all the process. And we began our first clinical trial in November 2019. Afterwards, I will focus on the technical characteristics based on our Unity installed. The Unity combined with the Physics 1.5 Tesla MR Marine and Electro 7 accelerator, and both geometry and environment of Unity 3 are different from the conventional radiotherapy devices. The Unity system is a bone-type machine where the linear accelerator rotates around the MR system. The inner part shows in pics the MR system. The outer part is an all-shaped accelerator with several important components, including the RF module factor, waveguide system, control gain modulator, PSU, wide accelerator tube. The right figure is the day just assembling was complicated. We can see that the accelerator is a little bit higher than the height of a person. The composition of the Unity is quite, what's the difference of that? Besides the 1.5 Tesla MI, 7 MV 3F high-end X-ray, the SAD is 143.5 centimeter, and the coach can only be moved in and out of within the treatment area, no up, down, or left. The calorimeter is fixed at the angular 19 degree. The field size, you should notice that the maximum is only 57.4 centimeter times 22 centimeters. So we should choose the tumor wisely when we use the Unity. The 18 pale MLC lift width is a little larger, 7.1 millimeter, and we should avoid the 13 degree where the pipe exists. The TPS is only support treatment technique is 3D CRD and step shoot MRT. In the future, maybe the remat will be available. The effect of magnetic field on the depth curve can be seen clear in the figure. The length of the build-up region is shorter than those per simulated primary actor at Dmax enhanced by 1.9%, where the magnetic field is present. However, at a depth dose of two curves very similar, although the dose per simulated primary pattern is symmetrically lower with the magnetic field by average 0.5% between depth 5 to the 25 centimeter. An important effect cannot ignore is the electronic return effect, which shows here when no magnet. We can see the tragedy of the electronics. If there is a magnet, we can see that at the tissue L boundary where the Lorentz force forced the secondary electronic back into the tissue and cause those hotspots. So the electron is in fact also apparent at the end of the 13 centimeter phantom, where it enhanced the exit dose around 1 centimeter at materials. And another effect to the cross profile is in presence of the MR field, a radiation beam deposit those symmetrically along the central exit. The profile maximal and the cross line dose per numero shift laterally rated beam central axis. So the symmetric is mostly present at the field edge and significant in small field. The inline profile, which in the magnetic field direction remains symmetrical. So that's the very important characteristic of the magnet. How to, how many patients we admission in our Unity? The figure presents a relationship between the number of the patient and the time. The origin line is the cumulative number of the patient, while the blue line is the number of new patients per month, we can see the number of the patient per month is quite stable. And the disease site treated on unity covered from the head and neck cancer, thoracic cancer to the abdominal cancer. The top 3 disease sites treated in our hospital is prostate cancer, liver cancer and liver metastasis, and brain tumor. And for different kind of types is ATP and ATPase. That's a different 2 kind of adaptive mode. I will discuss more about this in later. And nearly 19% patients choose ATP adaptive therapy, and the rest nearly 20 patients choose the ATS. What's the difference between 2 procedures? We should come to the part 4, treatment procedures. The unit treatment includes 3 major parts. First is patient registration, the second is reference plan, and the third part is online adaptive plan. Let me explain it step by step. But the first thing first, patient safety is more important in MR-Linac because of the magnitude, the magnet. We have to ensure that good condition that the patient can communicate with the operators without. And the verification that the core ball and the core ball and the headset are working properly before it used. And we should use monitoring to make sure that the patient in a good condition throughout all the treatment process. And the unity treatment process are including as following. First one is patient preparation. We have designated area for changing clothes. Left figures is the patient changing room. And routinely inquired about the patient status. And hands-on detector checking of the patient. The right figures shows that 2 kinds of the ferromagnet detector devices. One is installed on the wall, the other is hands-on. Step 2 is input diagnosis and the course of treatment, which is exactly the same as the conventional Linac. And routine MR safety assessment is quite important, cannot ignore. The assessment table lists the yes or no rated question listed on the right green box. We should notice that scan is not recommended if any unclear situation existed. Let's come to the step 4 is the CT simulation. Install the CT overlay on the CT simulate bed board and zeroing the sagittal laser light. And we should place the unity software caution on the CT overlay, and we designed the customized index bar to make it fixed to each other. Patient setup and immobilization should use the MR comparable positioning and immobilize the devices. Avoiding the formation of the loops and unnecessary skin contact on the patient to avoid the peripheral nerve irritation and burns. And we also play a neat point at the reference center marked by laser light and used to identify reference center during the plan design and record the position of the reference center related to CT over mark. And performing CT investigation of the obtained reference to CT scan. The region of interest contouring like conventional Linac treatment, the target and OR should be contouring. And since the ATS adaptive process is the dose calculation optimized on the shoulder CT generated from the current pre-treatment MR image, the relative electronic density distribution of the shoulder CT is filled in the broker filling of average relative electronic density segment from the reference plane image. So it's recommended to supplement the conventional radiotherapy organ outlining by contouring the tissue with a large density difference, such as the bone here and the cavities. The reference plan is similar design to the conventional MR-Linac plan, but the key difference is listed here. Adding a treatment coach model with input marked position and reference point relative to the coach bed. Add MR coil to account coil attenuation to the harmonics, and define the generation mode of the ROI when it's automatically segment in a adaptive plan. There were 4 types of the ROI type. First is deformation, second rigid, the other third is margin, and the other is user defined. And the setup an overlap of each ROI determine the block filling, priority order, relative electronic density for adaptive plan image segmentation. And we should review the reasonableness of the relative electronic density of each ROI. At the same time, the plan is prohibited to set the gantry angle at 13 degrees around the pipe. The pre-treatment image acquisition is a pre-treatment image verification, including the scan is initiated in treatment section management according to the scan sequence set in plan of card. After scanning, the image was automatically imported into online Monaco and automatically registration with the reference image. Determine the adaptive process based on the registration result. Step 8 is image registration and the registration result review. The registration method is based on the clinical consent, and for ATP, focus on the target area and the alternative mark. For ATS, the focus on the bone markers, and then the adaptive plan. Adaptive plan, more detail about the adaptive plan we have discussed in the later, and the BIM treatment including validation image, motion management, in therapy image and the post-therapy image. The very important things that you have to mention here is the beam on and the monitoring in therapy. Acquisition of 3D triple orthogonal cross-section imaging during the therapy is for real-time monitoring of the motion of the target predefined. The green line is the predefined motion management area. Mostly we choose the PTV. Unity provides 3 static orthogonal plane 2D scene MR image. If the target is out of the predefined area, we will stop the beam on manually. How about time for each process? We can see that the total time for ATP and ATS is quite different. ATS take more time, but as time goes by, our team have more experience on that. For ATP, the total time decrease from the 13 minutes to the 25, and for the ATS, initially we need nearly 1 hour. Right now, it's below 15 minutes. And we should notice that in ATP mode, the time spent on adaptive plan is dominant. And while in ATS, ROI delineations and adaptive plan are the top 2 time-consuming process. We also list the time for each step for Unity in select 5 cancer. It took a lot of time to do the ROI declinations, and the adaptive plan steps in prostate cancer patient, while other disease sites such as rectal cancer, liver cancer, and adrenal gland is beyond time. So how to reduce the time for the time-consuming process, such as the adaptive plan and the ROI declinations? Maybe in the future, automatically or the AI will be help. How about let's go to the fifth part of planning. There are two major categories, being the adaptive position (ATP) and the adaptive shape (ATS). For ATP, no daily deletions is needed. Only the isocenter position is updated in the pre-treatment CT, while for ATS and the daily MR can be recontouring to be used to adapt to the treatment planning. For the adaptive position, based on the result of rigid registration of pre-treatment MR with the reference image, corrections are made for changing in the position of the target area without correctioning for changing the shape of the target area and OR, suitable for the case with a small set of error and small RI distortions. Adaptive planning for optimization and dose correction on reference CT image. Non-modified of the target or OR, unmodified optimization conditions and parameters. So we can simply regard it adaptive position is a kind of a position error correction. In the conventional Linux, we use the Cauchy shift, while in the Unity, we just adjust the plan. How about the adaptive shape? Based on the result of deformation alignment, both the changes of position of the target area at the time of the current treatment are compositioned for the change of the shape of the target and the target OR correct. It's suitable for the case with large alignment error or the large ROI distortion that cannot be ignored. Adapt plan is optimized and those accurate on pseudo CT generation based on the current pre-treatment image. Target area and critical OAR contouring can be modified. Optimization condition and parameter can be modified. That's why ATS take is a kind of the more time-consuming process. For the adaptive plan, there are 4 adaptive models available in the Monaco system. The first one is origin segment. Shift the segment to the reference plan over or around the registering arrow, but don't change the shape, MU, or weight of the segment. The second is adaptive segment. General adaptive plan segment shape based on the BV projection of the target and the segment a partial morphing algorithm without changing the number of the segment MU. Optimized weight is SAM plus segment weight optimization, while the optimization shape is do more with the SAM plus the SWO and the segment shape optimization. We should notice that from the first one, original segment to the optimized shape, the planning time is increased, while the quality of the plan also increased. So as a physics, you should adjust this time and the plan quality to find a balance and find which mode is more suitable for your clinic. How about the segment after morphing? SAM is the first step of the adaptive plan. The SAM process does not optimize segment weight. No additional detect of the segment. SAM is, look at this picture. SAM is immersing inside the target, remain their relative distance from the edge of the detector, and the MLC outside the target will retain the absolute distance with the edge of the target. The typical case we used in our unit, we adopted your unity is brain tumor, liver cancer and liver metastasis, prostate cancer, breast cancer, rectal cancer, cervical carcinoma, and head and neck cancer. Let's go to the brain metastasis first. We can see that the isolated line distribution here with no MAC with and with MAC are normally the same. If we look into the dose volume histogram, Both plans meet the clinical requirement, but more hotspot in target areas such as GTV and PTV with the magnet, which are shown in dashed line. How about the liver metastasis? This hyperfraction and the prescription dose to IGTV is 16 gray in 5 fraction and 15 gray to PGT in 5 fraction. We use 7 beam, and both 2 beam you can see plants. You can see that meet clean requirements. But if we look hard into the slide by slide or the DVH, we find more hot spot in MRT plan with MAC. How about the tumor larger in liver metastasis case? We use the fraction about 15, and the procedure to PTV is 49.5 gray, and the CTV is 16 gray. We use 5 beam, as we found that both plans met clinical requirement and no significant difference in plan quality. But we can see both plans have hot spot. For rectal cancer, the prescription dose is up to 25 gray in 5 fraction, but our plan design is under we will use the 15 gray because we hope to more tiny dose distribution, and we use 9 beams. Both plans meet clinical requirement. No significant difference in plan quality. We can see that the dashed line from the unity and the solid line from the no MAC touched each other. In prostate cancer, we find both plans are meeting clinical requirement and comparable. No significant difference from the both target and ROI. If you look at slide by slide, both the plans are looked the same. How about the head and neck cancer? We found that in head and neck, we need to do more work. In order to quality evaluate the ERE, introduce those increment in tissue L interface. So the skin was contoured to include the first 1 millimeter on the outline of the body, and the interface of the tissue containing air cavity was contoured to include the first 1 millimeter outside the air cavity, such as nasopharynx, oropharynx, and larynx and trachea. We found that if we just apply the MRT plan with no MAC to the shift MU and the weight to the plan in unity, we found that the plan quality seems not good enough. So we have to do all re-optimization of the plan to increase the feasibility to achieve a clinical accepted treatment plan for hyperphalangeal cancer. There is a significant reduction in skin dose in present 1.5 magnetic field, and no significant difference in dose at the border of the tissue containing the air cavity, except for the max dose increased in the larynx and the trachea. So in the head and neck cancer, we have to carefully about it and need to re-optimization. For the non part, the GPU MCD algorithm in Monaco compared with the Gen 4 shows a good agreement in the present and absent in 1.5 external field. And we should notice that the application of 1.5 Tesla ML field dramatically changed in the dose in the junction of tissue different density from the water to lung, lung to tumor, tumor to lung, lung to water, with the dose increasing, decreasing, depend on the density of the material in each side of interference. So how about breast cancer? For the breast cancer, the ERE effect is more obvious. And to avoid this, skin declination is quite important for whole breast irradiation, and the contour of the skin should a little bit larger than the area of the breast, the whole breast area. And in the whole breast irradiation, the treatment of the patient in the MR-Linac use the conventional tangential whole breast irradiation setup or 7-field whole breast technique at 0.35 Tesla and or 1.5 Tesla, increasing a skin dose of the breast. While in the partial breast irradiation, skin dose and ROI dose are relatively low and little affected by the magnetic field. How the effect of the cavity on the skin dose? How to we should be very careful about this. The MR-Linac treat superior length should avoid the L gap between the bolus and the skin dose, because if you look at the gaps, L gaps around 5 millimeter with just the beam angle around the 15. The result of dose of 15.6 reduction in dose, while in conventional Linac is only 6%. Because we should notice that the TPS generally overestimates the skin dose. There's two reasons for that. The median grade sighting available is 1 millimeter, and the energy cutoff in the GPU MCD algorithm calculation in Monaco maybe also affect the accuracy of the result. Finally, is the future perspective. The first I think there are 4 major future perspective in the MR-Linac. One is real-time adaptive and gating. It will help introduce the number of the treatment fraction, also reduce the tolerance, even to cure some disease. And the function image will help the target the biology target and integral function image complete precise treatment to biology target. The application AI in all aspects of treatment speed up the process including automatic contouring, automatic tracking, or automatic adaptive planning. And MR-guided particle therapy of the proton and heavy ion is a new opportunity for personalized treatment and dramatic reduction in toxic-sparing non-malignant tissue for radiation effect. Let's come to the summary. The 2 main clinical drives for use the MR-Linac are the ability to image anatomic change that occur before and during treatment to adjust the treatment, and to image localization biology features of each tumor. In MR-Linac, indeed able radio planning for the patient, define the planning for the pre-treatment image in conventional radiotherapy. MR-Linac has their own unique dosimetric characteristics that distinguish them from conventional Linac. The online adaptive plan radiotherapy approach should select the case wisely due to a trade-off between the time spent in adjusting the treatment planning and the dosimetric benefit. Okay, thank you. That's all.
Thank you, Dr. Jiayun. This is excellent presentation. I really feel amazed with your presentation. We do have some question from the participants, and I will read from the beginning. There is a question. So from Mohniaskan, what is the spin echo technique in MRI? Do you want to collect the question or one by one to answer the question? How do you think, Dr. Jiayun?
Okay, so which one should I begin?
The first one from Mohniaz Khan in the Q&A answer. So the question is, what is the spin echo technique in MRI? Okay, so should I share the screen of the question, or is it is easy for you to read my list of questions? Oh, there are few question more. Okay, can you answer the first one or?
Sure.
Yeah,
Let me go to the previous slide, and maybe I ignore this part. Let's move this one. Okay. The predefined treatment image acquisition is the initial instrument section management, which according the scan sequence in plan of care, they are T1, T2, and because T1, T2 is a little bit longer, so we use the elector provide T1 3 minutes and T2 3 minutes. And you should notice that the emotion management is a balance BFFE echo to that's a 2D MS sim it's a movie in a movie mode. So but it can only provide 3 slides of each time.
Okay, is that answer the question? Mr. Nias Khan?
Okay, ma'am.
Yes. Okay, thank you. So I will go to the second question. As you said that the SAD is 143.5. So are all beam data profile measurements done at 100 centimeter or at 143.5 centimeter?
Okay, that's a good question. Let's go back to the slides. First is the configuration of the unit here. As you see, here that's a good one. Okay, as you see that this slide, they're all altering is the Linac, entering the MR-Linac, because they want to put 1.5 Tesla marine is already used widely in the it's a widely used MR scanner, and they just put inside it. That's why they use the orange shaped Linac, and that the SAD. As we all know that SAD in convention is 100 centimeters, so that's why the SAD become larger in this unit. And any question? Other coach? Oh, you see the coach, and they use the coach exactly the. That's a nice question. Okay, let's go to the figure here. Yes, that's the in-room picture, and you can see the coach can move up down, but here, but inside the Linac they cannot move up down.
So that's the question from Miss or Mr.
If they fix the, if they just the place here is just let the patient to go up to lay down on the couch, because some patients cannot easily get that higher, so they down the couch, and the patient lay down on the couch and right in the laser position. There are only one laser here, laser position, and move into the MR-Linac. The other okay.
Okay,
Any other
okay.
question?
Yeah, the other question, you said that the coach can be shifted only in and out direction. Then what happens if treatment depth change? Then can we shift the coach in vertical direction?
Oh, that's a good question. That's because the manufacturer did not allow us to shift their coach. They fix the coach and they like you to shift their plan. You know, they just
Okay.
they think that you can use the image to correction the setup error.
Oh, okay. Excellent. Okay, can we go to the next question? Yes, this is the question from Mr. Rajesh Kinikar. So what are the challenges with breast patient with wing bore with limited bore diameter? And the second one is, do we have access to Linac delivery files to monitor intrafraction movement? So with the first question is related to the challenge with breast patient with wing bore with limited bore diameter.
If for the breast cancer, they could not use wing board. Because you use the wing board to help the patient to not make the patient safe, and there is no communication of the whole body to avoid it like this. You can also put the hands down or up. The wing board is kind of option. As you can see the monitoring here, you can see the patient here, hands up. Any questions?
And the second
Do you have the unique derivative to monitor interface? Oh, that's a good question.
Yeah, the
Linac That's a good question. Right now they didn't provide the monitor interface, the Linac delivery files, monitor, but I'm working on that. We used we generation a new sequence to monitoring the inter and intra fraction movement, and we can use the image to which image with the higher spatial and time temperature than the image provided by the commercial one, and we can see more details about this. And if we have a chance, we can discuss more about this if there is another opportunity. That's a long story.
Okay, and we have many questions. This is interesting. Are you going for only 3D based sequence, or are you acquiring 2D sequences and functional sequences also?
Yes, we do, but not in clinic mode. Because for the Unity, the company don't allow us to modify any sequence in the clinic mode. So sometimes we will do the research after the cognitive procedure finished, we will scan the extras such as DWI sequence or the motion management the sequence I'm working on here. But that's all after treatment.
Okay.
Okay.
Another one. Have you used MR only planning from Unity without having planning reference CT?
How do you do only plan? Oh, here come to the here. Yes, we mentioned here, but not here region of the contouring. I mentioned here, but not very, maybe not very clear. The shooter see the we registration MR and the retinal scan MR and registration with the pre-treatment CT and the shooters the MR will the no density on MR, but we will generate a shooter CT based on the treatment MR right now, and the relative electrical density distribution of shooter CT will filled by the block. What's the logic of the filling block? That's by the contouring, what are you doing? Such as we define the contouring type, including deformation, rigid, and margin, and user define. Sometimes the PTV and the GTV, the GTV is the deformation which transforms from the CT to the MR and generating use deformation algorithm. And the PTV sometimes is a margin, is a kind of margin generated by automatic stent algorithm. So that's what we do, and we have set all lap order of each ROI to determine the filling priority of relative density to adaptive plan image, which listed here. You can see we always put the GTV boost and IGTV first, and then nearby the ROI, including kidney.
Seven. And next question, have you used MR only plan? Oh, sorry. The new MR-Linac, is the new MR-Linac have VMAT?
No, not yet. As I
Okay.
know, I'm looking forward that. As you can see that we already know that VMAT is widely used. If you look at the plan cognitive of the VMAT for the rectum cancer, that the no so many hotspots in the VMAT. So the plan cognitive I compare here is MRT with MEG without MEG.
Okay. Another question is, how you are managing the motion management? Are there any devices that you used to manage?
Oh, that's a good question. We use for the liver metastasis cancer and the liver, you know that it will be affected by the motion, and that's why we use the abdominal compression belt to reduce the magnitude of the motion of liver. That's what we do, and we also maybe in future we are coaching the patient about the deep breath.
Yeah.
But that should for the deep breath we should based on the 4D MRI, but not available right now in our clinic. Maybe in the future we upgrade, and maybe we can do that more.
Okay, and another question, and this one. How MR-Linac deal with the implant, with the patient with implant? Is that what you mean?
That's a good question, and we have to do the initial assessment here. Initial MR adaptive assessment, including the listed here, such as the implant wave and the pap maker, and if it MR safe, we will adopt this patient in MR-Linac. But if not, maybe we can not take that risk.
Okay. Is that the question already answered? Because Mr. Abid Ali raised his hand. Are you going to
I can talk
address
now.
your question? Yeah, maybe you want to add
Can you hear me?
some.
Hello, can you hear me?
Yes, yes,
Yes,
yes.
I can hear you.
Okay, my
Please.
question is regarding the motion management that I said earlier. It was about more like, are you guys using Vital Eye or something like this to manage the abdominal motion or something? Or if you are for the breath hold, like what you said, for deep inspiration breath hold, is there any additional device that you use to manage these things? Can you please answer this?
Right now, not yet in clinic. Only
So that
only abdominal compressed belt.
okay, no Vital Eye, right?
No. Maybe you see something, some presentation from other, in APM or Astro, they used guidance about the monitoring, but not yet in our hospital.
Okay. So we
Thank
have
you,
many
Chen. Thank you very much,
questions.
Chen.
Yeah.
Good afternoon.
Excellent. Okay.
Good
And
afternoon. Are you here?
okay. Oh, Prof. Regis Kumar, would you like to add some
Are you
questions?
listening from the India?
Yes, Prof. Regis Kumar,
Listen-
please.
Yeah. The Linac can be used for treatment only, or Linac can be used for creation of the images.
Pardon? I cannot hear clearly.
Yeah, it's a little bit, maybe you can write in the chat. It's better because the voice is not clear. Okay. And there is the question, can the IKRT be taken and what algorithm used for treatment? And can we treat the TBI patients? There are two questions from Miss Tracy Evangeline. Prof. Regis Kumar,
Oh.
please write down your question, maybe better for us.
The AGRT is MR-Linac is based on the MR. That's the IGRT used on MR-Linac. As I mentioned before, we used the T1, T2 images to taken. Or if you want to know use the function, maybe DW available right now. And what algorithm used for treatment? Do you mean that what's the algorithm in TPS, right? If I please correct me if I don't think it very okay. Maybe you mentioned, I think you are mentioned about this one. Let's come to the here. Okay, the algorithm is GPU Monte Carlo, GPU MCD algorithm in Monaco system. It's a kind of likelihood of Monte Carlo system, not exactly Monte Carlo system, as I mentioned here, because the energy cutoff in GPU MCD calculation algorithm is not reasonable that you factor the accuracy the result. Especially the TPS generally automatic the skin dose in this based on this study, because this study compiled the GPU MCD calculation with the measurement. And in previous slides that I mentioned here they used the phantom and they measured they used the GPU MCD algorithm and compare with the well-known Monte Carlo simulation Gen 4. They show the very good agreements here. You can see that the dots and the solid is attached to each other and they perform very well.
Okay, that's the answer. And another question is from Mr. or Miss. Pardon if I mistake. Mr. or Miss Gopi Sankar, do you treat multiple metastases or multiple targets? What is the integral dose in comparison with other techniques? Is there any quantification done till now?
Yes, we treat we also treat liver metastasis and large such as the brain tumor. Most of brain tumor are metastasis. And which integral dose compare with other technique? We compare the dose with the MRT without MAC. They are comparable based on our study here. This is the brain metastasis here. And we also treat 3 or 2 targets in brain metastasis, but I not show here. You can see that this is the very small metastatic tumor here. If you look at larger, you can see the liver metastasis case here. The comparable MRT without. As we all know that the basic knowledge we matter is much better than the MRT. So that's why we are looking for the VMAT available in the MR-Linac. There may be some technical problem or the so that's we need to they may need more time to fix it. The presenter can.
Okay. And okay, this is another question from the same participant. It's supposed to in Electa Unity, Monaco TPS is used for planning. Is there any additional planning algorithm module added, or the same MC algorithm is used in planning?
That's a good question. We use Monaco TPS for the planning, and in other published paper, they use the RayStation for the plan verification, online verification. They transfer Monaco TPS, the plan generated by Monaco TPS to verification the online adaptive plan is good or not.
Okay. And the last question from Prof. Rajesh Kumar. Linac can be used in treatment only or image creation also?
Can be used during treatment only. They we not do that yet.
Oh, okay.
Image can be used image only. We use the image only to define to clarify that whether this patient is okay to is in good condition to treat in this unit, because sometimes the visualization of the tumor, if it's too small, it may not visualize in MR.
Oh, okay.
Because we use the location the tumor to do the adaptive planning.
Excellent. Also,
Okay,
I
thank you. Ma'am, thank you very much.
thank you for all the question answered from Dr. Jiayun. This is excellent presentation because there are many questions from the participant, and I'm very happy to moderate the question to deliver to you. And because we almost in the end of our webinar, so in conclusion, I would like to deliver big thanks to Dr. Jiayun for her insightful contribution and our audience for their participation. I hope this seventh webinar, AFOMP webinar is very has been informative and engaging for all of you. In conclusion, I will like big take home message that the main clinical driver for the use of MR-Linac are the ability to image anatomical change and that occur before and during treatment to adjust treatment and to image and localize the biologic feature of each tumor. And I have big thank to all the participant and especially for Dr. Mary John and Prof. Chin and Dr. Jiayun for the webinar today. So Dr. Mary John, do you would like to
Yes.
say something to
Yes,
close
yes,
this
yes.
webinar?
Thank you, Dr. Noor, for wonderfully organizing today's webinar, and thank you, Dr. Jiayun, for very wonderfully explaining all the details and basics to advanced techniques of clinical applications of MR-Linac. Thank you very much. And I would like to inform you all that our next webinar will be on 14th October, Saturday, on X-ray digital breast tomosynthesis for cancer screening and diagnosis. Dr. Cho from Korea will be delivering the talk, moderated by Professor Hasin Anupama from Bangladesh. A hearty welcome to all of you, and thank you all the participants for your active participation and coming up with very interesting questions leading to a very active discussions. Hope to see you all on 14th October for the next webinar.
Thank you.
See you all there. Bye.
Bye-bye.
See you. Bye.
Bye. Thanks.
Madam, thank you. Thank you. Thank you very much. Thank you.
Thank you.
Thank you.